Good evening. Is it audible? Okay. Good evening. Good evening. Okay. Okay. Right. Right. So last day we started root locus. Last day we started root locus, and in the root locus we discussed where the root locus branch starts and ends. The root locus branch starting and ending direction depends on range of k value that we discussed in the last day. If in case k increased from 0 to infinity, the direction of the root locus branch we discussed from k equal to 0 where at open loop pole, k infinite at where open loop 0. The direction of the root locus branch is from open loop pole to open loop 0. In case k increased from minus infinity to 0, k increased from minus infinity to 0, the direction is 0 to pole, because here k is minus infinity, here k equal to 0, here k equal to 0. So up to this we completed. Next, angle and magnitude condition. Next topic is angle and magnitude condition. Angle and magnitude condition. Angle and magnitude condition. For what this angle and magnitude condition actually? See, there are total 8 rules are there. Root locus construction rules. We want to draw the root locus, 8 rules are there. All the 8 rules are framed basically by using the angle condition only. Angle condition very, very important. The construction rules of root locus are framed by using only angle condition, such that the root locus diagram gives closed loop poles path and closed loop system stability. Closed loop poles path and closed loop system stability. Closed loop system stability. That means what I can write the statement? The construction rules of root locus. The construction rules of root locus are framed by using angle condition, such that the root locus diagram gives closed loop poles path and closed loop system stability. Next, the closed loop system stability given by is given by characteristic equation. So when you say characteristic equation here, two things coming into the picture. One is what? Positive feedback, another one negative feedback. So what is the characteristic equation? General by default is negative feedback. By default is negative feedback. That means what is the characteristic equation? 1 plus g of s h of s equal to 0. 1 minute, I'll come. I'll forget the specs. Within a minute, okay. Okay. Right. Angle condition AC means listen by a here itself is there. I told angle condition. AC means angle condition. MC means magnitude condition. Angle condition. Okay. So by default, consider negative feedback. 1 plus GH equal to 0. But here problem is some students in the BTech what they'll study. So negative feedback means you have to draw the direct root locus. Positive feedback means you have to draw the inverse root locus. Like that they used to study. It is also wrong. What diagram you have to draw, that depends on the angle condition. Either you have to draw the direct root locus, either you have to draw the inverse root locus. That completely depends on the angle condition. So here, I'll take G of S. For example, only negative feedback I consider. I consider only negative feedback. But I'll take the two cases. Case one is G of S, H of S equal to positive K I will consider. K into N of S by D of S I consider. Case 2. Case 2. So I consider G of S, H of S equal to minus K into negative value I consider. K negative I consider. For example, minus infinity to 0 means I'll take negative value minus N of S by D of S. N of S means numerator polynomial in the S. And D of S means denominator polynomial in the S. Okay, na? I consider two cases. But feedback is negative feedback only I consider. There is a change. Why? Because which diagram you have to draw, that depends on the three factors. What you have to draw, that depends on three factors. So that is range of K and the system and the feedback. It depends on range of K, it depends on the system, and it depends on the feedback also. Feedback, system, and range of K. Three factors. Just I change, right? Taken negative feedback only, but I change in K. I taken different ranges of K. Now I'll write the characteristic equation. If you write characteristic equation, 1 plus K n of s by d of s equal to 0. N of s by d of s equal to 0. Here, what is the characteristic equation? So, substitute here g of s, h of s, 1 minus k into n of s by d of s equal to 0. N of s by d of s equal to 0. Now, from this, find the angle condition. So, I'll write in the next page. From this, you write the angle condition. From this, you write angle condition. What is the angle condition? K into n of s by g of s equal to how much? K into n of s by d of s equal to how much? Minus 1 plus j0. Instead of writing minus 1, I written minus 1 plus j0. What is the angle of minus 1 plus j0? Anybody? What is the angle of minus 1 plus j0? Minus 1 plus j0 angle. Angle of minus 1 plus j0. Plus or minus 180 degrees. Plus or minus 180 degrees. The other way, what I can write? At next, one more point, we'll write it, no problem. Here, what is k into n of s by d of s? K into n of s by d of s equal to how much? From this, you write, na? K into n of s by d of s. This one goes to other side, it will become 1. Minus minus become plus, na? That means it will become 1 plus j0. 1 plus j0. What is the angle condition? Angle condition. Angle of k into n of s by d of s is equal to angle of minus 1 plus j0. What is the angle of minus 1 plus j0? What is the angle of minus 1 plus j0? Is nothing but plus or minus 180 degrees. But it is not sufficient. It is not sufficient. Why? Because, see, listen. For example, if you write here angle condition, angle of k into n of s by d of s equal to what? Angle of 1 plus j0. What is the angle of 1 plus j0? 0 degrees. Not only 0 degrees, I can write here plus or minus 2 times of 180 I can write. See, simply under 360 degrees. Listen here, all of you. Listen, all of you. Where is the point? First of all, tell. Where is the point? Minus 1 plus j0 is here. This is minus 1 plus j0. What is this axis? This is imaginary axis. What is this axis is called? What is this axis? 180 degrees, na? Plus or plus 180 or minus 180? So this is nothing but plus 180. This is nothing but minus 180. That means what is the angle? It is plus or minus 180 degrees. So, but how many times? It may be 1 time. Even 3 times of plus or minus 180 also same. Or 5 times of plus or minus 180 also same. And so on. That means what you are getting? Odd multiples of plus or minus 180. Odd multiples of plus or minus 180 degrees. Negative real axis is called odd multiples of plus or minus 180 degrees. Or plus or minus 2q plus 1 into 180 degrees. Where q is 0, 1, 2 and so on. Substitute q0, 180. q1 is substitute 3 times 180. q2 substitute 5 times 180. What is this axis? Tell. 1 plus j0 means here. 1 plus j0. What is this line? What is this line? What is the axis? 0 degrees. Or 360 degrees. 360 degrees means I can write plus or minus 2, 180 degrees. 2 times of plus or minus 180. I can write 2 times of plus or minus or 4 times of plus or minus 180 or 6 times. That means what I can write this? Even multiples of plus or minus 180. Even multiples of plus or minus 180 degrees or plus or minus 2q into 180 degrees, where q equal to 0, 1, 2 and so on. 0, 1, 2 and so on. So that means positive real axis is called even multiples of plus or minus 180. Negative real axis is called odd multiples of plus or minus 180. Any point on the positive real axis is 0 degrees. Any point on the negative real axis plus or minus 180. It may be 1, it may be 10, it may be 20, it may be any value on positive real 0 degrees. It may be minus 1, minus 10, minus 20, minus 100. Any value on the negative real axis is plus or minus 180. Any value on the positive imaginary 90, negative imaginary minus 90. Finally, what is the angle condition? Tell. So, what is the angle condition here? Even multiples are here. What is the angle condition? For minus 1 plus j0, what is the angle condition you got? Odd multiples of plus or minus 180. Odd multiples of plus or minus 180 degrees. Or plus or minus 2q plus 1 into 180 degrees. Where q is 0, 1, 2 and so on. Here what you got? Even multiples of plus or minus 180. Even multiples of plus or minus 180 or plus or minus 2q into 180 degrees, where q 0, 1, 2 and so on. Okay, so this is the angle condition. See, same negative feedback only. I taken only negative feedback because I changed the range of k value. So once I got the what? Odd multiples I got it, here I got it even multiples. So if you are getting odd multiples of plus or minus 180 or a system which gives angles of plus or minus 180 degrees, so then we require to draw the direct root locus. In this case, you have to draw the direct root locus. So a system which gives angle of plus or minus 180 degrees required to construct the direct root locus. A system which gives angle of plus or minus 180 degrees, then required to draw direct root locus. Required to draw direct root locus. Direct root locus. Another word for direct root locus is, what is another word for direct root locus? Anybody? Or another word is 180 degrees rules diagram. 180 degrees rules diagram. 180 degrees rules diagram. Either you say 180 degrees rules diagram or direct root locus, both are same only. If you say 180 degrees rules diagram or direct root locus, both are same only. Both are same only. Okay, na? So both are same. So a system which gives angle of plus or minus 180 degrees, then required to draw direct root locus or 180 degrees rules diagram. A system which gives angle of 0 degrees, a system which gives angle of 0 degrees, then required to draw inverse root locus, or complementary root locus, complementary root locus, or 0 degrees rules diagram, 0 degrees rules diagram, 0 degrees rules diagram. So a system which gives angle of 0 degree, then required to draw inverse root locus or complement root locus or 0 degrees rules diagram. We have to draw it. Okay, na? See, same negative feedback because there is a change in range of K. One is given the what? Direct root locus, one is given the what? Inverse root. That's why don't mug up. What you have to draw means just you have to check the angle condition. Just we have to check the angle condition. That's all. What you have to draw means just you have to check the angle condition. Okay, na? Check the angle condition. So if we are getting 180 degrees, draw the direct root locus. If we are getting 0 degrees, then draw the inverse root locus. And one more thing, there is no much difference between direct root locus and inverse root locus. There is no much difference between direct root locus and inverse root locus. So I'll write the conversion from direct root locus to inverse root locus. Conversion tabular form I'll write. So direct root locus to inverse root locus. Conversion from direct to inverse. Conversion from direct root locus to. What are the change in 99.9%? They'll ask the questions only direct root locus. Why? Because they don't mention the feedback. They don't mention the range of K. Whenever they don't mention feedback, whenever they don't mention range of K, blindly you have to draw the direct root locus. Unless until mention positive feedback, negative value of K, something mentioned. If you mention something other than the what default conditions, then we have to check the angle condition. Then you have to draw either direct or inverse root locus. At the end, I'll discuss what diagram you have to draw, why you have to draw, that I'll discuss. How to check the angle condition, everything will come. No need to worry. Here, just conversion from direct root locus to inverse root locus. Direct root locus to inverse root locus. First, total 8 rules are there. Total 8 rules there. In rule 3, what are the differences? What are the there are only 3 differences from direct root locus to inverse root locus. There are 8 rules. In 8 rules, only 3 rules only changes. Remain all are same. Only 3 rules only changes. What are the 3 rules? What are the 3 rules? Means here itself gives the answer. These 3 lines gives the answer. These 3 lines gives the 3 differences. What are that? Here odd is there. Here what is there? Even is there. So that means in rule 3, there is a word odd. Odd replaced by even. Odd replaced by even. That rule is going to be converted to inverse root locus. Just odd replaced by even. Then that rule is going to be converted to inverse root locus. That rule going to be converted to inverse root locus. In rule number 4, in 4th rule, there is angle of asymptotes. What is the formula for angle of asymptotes? 2q plus 1 into 180 degrees divided by p minus z. This is the formula for angle of asymptotes. So whereas in inverse root locus, here 2q plus 1 is there. Here what is there? 2q. In inverse root locus, the angle of asymptote formula is 2q into 180 by p minus z. P minus z. And rule 8. So in the angle of departure, there is a formula. In the formula here, 180 degrees will come. So 180 degrees replaced by what? 0 degrees. 180 degrees replaced by 0 degrees. Then automatically what happens? That rule is going to be converted to inverse root locus. 180 degrees replaced by 0 degrees. Then that rule is going to be converted to inverse root locus. 180 replaced by 0 degrees. Then that rule is going to be converted to inverse root locus. That's all. Now, what is the purpose of angle condition? What is the purpose? What is the use? What we can do by using this angle condition? The angle condition we can use to check the any point lies on root locus or not. We can use angle condition to check the any point lies on root locus or not. Lies on root locus or not. Lies on root locus or not. To check the any point lies on root locus or not. Root locus or not. That means all the points on the root locus. That means all the points on the root locus. All the points on the root locus. All the points on the root locus. On the root locus must satisfies the angle condition. To check the any point lies on root locus or not. That means all the points on the root locus must satisfies the angle condition. The angle condition must satisfies the angle condition. Angle condition. So point is there on the root locus means it should be satisfy angle condition. So what is the angle condition? Default is direct root locus. Default is direct root locus. Forget about inverse root locus. I'll discuss inverse root locus at the end. First concentrate only on direct root locus. So any point is there on the root locus branch means that should maintain the angle of what? 180 degrees. That should maintain the angle of what? 180 degrees. That's why we can check it. If it is gives angle 180 degrees, then it is on root locus. If it not giving angle 180 degrees, then it is not on root locus. Okay, na? So the angle condition we can use to check either the point lies on root locus or not. Either the point lies on root locus or not. Okay, na? So what is the angle condition? Odd multiples of plus or minus 180 degrees. Note down one problem. You note down one problem. Come on. Note down one problem. Check whether the following points lies on root locus or not. Following points lies on root locus or not. Check whether the following points lies on root locus or not for given system. For given system. G of S, H of S equal to K by S into S plus 5 into S plus 10. First point to take S equal to minus 3. Second point to take S equal to minus 7. Come on, check it. Come on, do it. Come on, do it. So first angle condition. You have to apply angle condition. AC means angle condition. First take the first problem. At S equal to -3. So G of S, H of S at S equal to -3. The angle of G of S, H of S. So angle of K by angle of S, angle of S plus 5, angle of S plus 10. Now substitute S equal to -3. If you substitute S equal to -3, what you are getting, tell? Angle of K divided by angle of S. S is equal to -3. So -3. Here -3 plus 5. Substitute S equal to -3. -3 plus 10. Now come on, get the answer. So what is the answer? That equal to angle of K by angle of -3, angle of 2, angle of 7. So angle of K is 0 degrees. K is a what? Any value from 0 to infinity. Default value of K is 0 to infinity. Any point, just now only I told. Any point on the positive real axis, any point, it may be G1, 2, 3, 4, any value. So up to plus infinity, what is the answer? 0 degrees. K is by default 0 degrees. So 0 degrees divided by angle of -3 is plus or minus 180. Angle of 2 is 0 degrees. Angle of 7 is 0 degrees. What is the answer you are getting? 0 by angles added or subtracted. That means one time of minus or plus 180 degrees. So that means what? Odd multiples of plus or minus 180. Odd multiples of plus or minus 180. Satisfied angle condition. Given point on root locus. Satisfied angle condition. AC means angle condition. Satisfies angle condition. Angle condition. Given point on root locus. Given point on root locus. Given point on root locus. That's all. So similarly, check for -7, all of you. Check for -7. Verify -7. Check -7. Is it lies on root locus or not? Similarly, second bit. Second bit. S equal to -7. Actually, if the point is real, we can identify directly if you know the real axis root locus branch. There is a third rule. There is a third construction rule. By using that directly, we can select the answer. It will come later. So G of S, H of S, I will tell how to identify directly. If the point is real, directly you can identify. So angle of K by angle of S, angle of S plus 5, angle of S plus 10, angle of S plus 10. That equal to angle K by angle of minus 7, angle of minus 7 plus 5, angle of minus 7 plus 10, minus 7 plus 10. That equal to angle K is 0 degrees divided by angle of minus 7 means plus or minus 180 degrees. So here angle of what? Minus 2. Minus 2 means again plus or minus 180 degrees. Yes or no? This is minus 2 only, na? So minus 2. Angle of minus 2. Any point on the negative real axis plus or minus 180 degrees. So positive real axis 0 degrees. Next here plus 3. This will become what? Plus 3. Angle of plus 3 is 0 degrees. So what you are getting tell here? 2 times of plus or minus 180 degrees. 2 times of plus or minus 180. That means what? Even multiples of plus or minus 180. Even multiples of plus or minus 180 degrees. Plus or minus 180 degrees. So, not satisfies angle condition. Not satisfies angle condition. Given point not on root locus. It is there on inverse root locus actually. So it is, why? Because what is the angle condition for inverse root locus? Even multiples. So not satisfies angle condition for direct root locus. You want to write it. Not satisfies angle condition for DRL, direct root locus. So given point not on direct root locus. Given point not on direct root locus. Direct root locus. RL means root locus. But we can write the note. The above point lies on inverse root locus. The above point lies on inverse root locus. Lies on inverse root locus. The above point is lies on inverse root locus. Lies on inverse root locus. So like this, you have to check the angle condition. If you know the third rule, directly we can identify. If you know the third rule, we can identify directly. That will come later. No need to worry. I'll discuss. So third rule, I'll discuss it. Okay, na? No need to worry. Right. Plus or minus 180 minus or plus 180. Both are same axis. One is in the clockwise direction, one is anti-clockwise. This direction plus 180, this direction minus 180. Right. So next, same axis, only which direction you are taking the angle based on that. This is plus 90 or minus 270. This is what? Minus 90 or plus 270. What is there? Next, magnitude condition. Magnitude condition. What is the magnitude condition? Either it may be positive feedback or negative feedback. The magnitude condition not changes. So by default, if you consider negative feedback, 1 plus g of s h of s equal to 0. What is g of s h of s? G of s h of s equal to bolo minus 1 plus j0. What is the magnitude condition? Magnitude condition is magnitude of g of s h of s is equal to what? Magnitude of minus 1 plus j0. What is the magnitude of minus 1 plus j0? 1. That means magnitude condition is nothing but 1 only. That's all. Magnitude of G of S, H of S equal to 1. Equal to 1 at any point which is on root locus. 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 Magnitude of G of S, H of S equal to 1. At any point which is on root locus. Which is on root locus. That means what? All the points on the root locus must satisfy angle condition. So once angle condition satisfied, then we can apply magnitude condition, because any point which is on root locus means the point lies on root locus means what? Angle condition must be satisfied. So angle condition must be satisfied. Once angle condition satisfied, then only we can apply the what? Magnitude condition. Magnitude condition is valid to the points which lies on root locus only. Magnitude condition is valid only to the points which lies on magnitude condition. Magnitude condition is valid only the points lies on root locus. The point lies on root locus. The point lies on root locus. Magnitude condition is valid only the point lies on root locus. That means the angle condition must be satisfied. That means angle condition should be satisfied. Angle condition should satisfied. Satisfied to apply magnitude condition. To apply magnitude condition. Magnitude condition. That means when you want to apply magnitude condition, first we need to verify the angle condition. If angle condition satisfied, then we can go for the what? Magnitude condition. First you have to check the angle condition. If angle condition satisfied, then only you have to go for the what? Magnitude condition. Okay, na? Then only you have to go for the what? Magnitude condition. Okay. But what is the purpose of magnitude condition? Purpose to find the system gain. To find the system gain. To find the system gain at any point which is on root locus. At any point which is on root locus. Which is on root locus. To find the system gain at any point which is on root locus. Which is on root locus. So purpose is finding K. System gain means K. So magnitude condition mainly required to find the system gain K. To find the system gain K. ठीक है ना? To find the system gain K. Right, very good. Next. So now note down one problem. Note down the one problem. Next page I'll write. Note down one problem. Find the system gain. Find the system gain. System gain K. At a point S equal to minus 4 plus J4 to the given system. To the given system. G of S, H of S equal to K by S into S plus 8. Come on, do it. First, verify the angle condition. First, check the angle condition. Then go for the magnitude condition. Come on, Guruji, come on. Is it satisfies angle condition? Yes. Check it. Satisfies or not? First, verify the angle condition. So, where you want angle condition? G of S, H of S at S equal to minus 4 plus J4. That equal to angle of K by angle of S, angle of S plus 8. Angle of K by angle of S, angle of S plus 8. Now substitute minus 4 plus J4. So angle K by angle of minus 4 plus J4. Angle of minus 4 plus J4 is substitute here. Then what I will get? 4 plus J4 I will get. 4 plus J4 I will get. Now what is the angle tell? Minus 4 plus J4. So angle of K 0. What is the angle of minus 4 plus J4? How we will find the angle? Simply tan inverse of what? Imaginary part by real part. But you should observe in which region the point is lies. Some people minus 4 by 4 mean tan inverse minus 1. They'll write minus 45 degrees, which is wrong. Minus 45 degrees is wrong. So listen, this is very, very important. Writing the angles are very, very important. If you are unable to write the angles, then you will lose the marks. Even in the polar plot, Nyquist plot, anywhere. For control systems, you should follow this. Not only control, all the subjects. So, for example, see, listen all of you. For example, this is pastoral. This is pastoral. This is positive imaginary. Negative imaginary. Negative real. Bolo. If the point lies in the first region, in case here, for example, point lies in the first region. So what is the angle tell? Like for example, plus 1 something in the first region, for example, some value. So positive real, positive imaginary, plus j omega axis, for example, plus j omega. So positive real, positive imaginary. What is the angle tell? If the point lies in the first region, what is the angle? What is this angle? What is this angle tell? What is this? Simply tan inverse of imaginary part by real part. Any point lies in the first region, simply it is tan inverse of imaginary part by real part. Tan inverse of imaginary part by real part. If the point lies in the second region in case, like this. So this angle, the negative real and positive imaginary, negative real, positive imaginary. What is the angle? Here, one thing you have to learn, all the angles should be taken only with respect to 0 degrees. All the angles should be taken only with respect to 0 degrees. You should not take one angle is 0 degrees, one angle is 180 degrees, one angle with 90, one angle with minus 90, should not take. So even in the calculator, if you enter negative real by positive imaginary, that gives the angle with respect to 180 degrees, which is wrong. You should not select the angle with respect to 180, which is wrong. All the angles should be taken with respect to 0 degrees. So what is this angle? What is this angle? Here to here is what? 180 degrees. But it is not 180, na? It is having less than 180. So that means what is the angle? 180 minus theta. This is simply theta. This is simply theta. That is equal to tan inverse. But here what happened? 180 minus theta. That means what is the angle? 180 minus tan inverse of imaginary part by real part. If the point lies in the second quadrant, the angle is tan inverse 180 minus tan inverse of imaginary part by real part. If the point lies in the second quadrant, the angle is 180 minus tan inverse of imaginary part by real part. In case negative real, negative imaginary. This is what negative real. This is what negative imaginary minus j omega. Negative real, negative imaginary. This point. What is the angle for this tell? It is more than 180. Up to this is 180. So 180 more than 180. 180 plus theta. What up to this 180? It is more than 180. Na? So that means third quadrant angle is 180 plus tan inverse of imaginary part by real part. 180 plus tan inverse of imaginary part by real part. 180 third quadrant angle is 180 plus negative real, negative imaginary you are getting. Here what happened? Negative real, positive imaginary second quadrant. In case minus 4 minus j4 is there, then you have to write 180 plus tan inverse of imaginary part by real part. Next, fourth quadrant. So positive real and negative imaginary. Positive real and negative imaginary. Positive real and negative imaginary. What is the angle? This angle you have to write. What is this angle? Simply minus tan inverse of, this is minus theta simply. Minus theta means minus or theta equal to this angle for theta, I'll write theta equal to minus tan inverse of imaginary part by real part. Minus tan inverse of imaginary part by real part. Fourth quadrant is simply minus tan inverse of imaginary part by real part. Minus tan inverse of imaginary part by real part. Like this you have to write the angle. Based on which region the point lies, you have to write the angles. No sir, I will go by this direction. Means you can go by this direction also, minus theta. Here it is what? Minus 180 plus theta. Minus 180 minus theta, like this. But better go by only positive direction. Better use only positive angle. Plus 180 only use in the angle calculation. Better use positive angles. Why to take mine? Same answer you will get. Either take positive or negative. The answers are same. If you go this side, negative angles up to this minus 180, minus 180 minus theta, minus 180 plus theta, like that will be there. But better use only this directions. Okay? Come on, now calculate it. Now write the angles for this. Come on. What is the angles tell? Angle of K by, come on. Already we written, na? Angle of K is 0. Any point on the positive imaginary 0 degrees. 0. On this 0, 0 divided by minus 4 plus J4. What is the angle tell? Negative real. Dekho, negative real, positive imaginary. Which region? Negative real. Like this you can represent negative real, positive imaginary. Positive imaginary. Which region? Second region. What is the angle? What is the angle? 180 minus theta. So 180 minus tan inverse of imaginary part. How much? 4. Don't write sign here again. Imaginary part 4 by real part 4. You should not write the sign here again. Because of the sign only 180 minus you got. So 180 minus tan inverse of imaginary part 4. Imaginary part 4. Real part also 4. Don't write again minus 4. Because of that minus 4 only we got 180 minus theta. Next, plus angles are added na. So what happened? It is first quadrant, positive real, positive imaginary. First quadrant, simply tan inverse. Tan inverse of imaginary part by real part, 4 by 4. So these two cancelled. What is the answer tell? 0 by 180 means simply minus 180 degrees. Satisfies angle condition. Satisfies angle condition. Given point on root locus. Given point on root locus. Direct root locus. Then we can apply magnitude condition. Magnitude MC means magnitude condition. So magnitude, what is the magnitude condition? Simply magnitude equal to 1. Magnitude equal to 1. So that means magnitude of G of S, H of S at S equal to what? Minus 4 plus J4 equal to 1. Minus 4 plus J4 equal to 1. That means K by magnitude of K by minus 4 plus J4 into 4 plus J4. 4 plus J4 equal to 1. Minus 4 plus J4. 4 plus J4 equal to 1. Come on, write the magnitude. So magnitude of K by root of what? Root 16 plus 16. Again root of 16 plus 16 equal to 1. K equal to 32. K equal to 30. This is the answer. K equal to 32. K equal to 32. Okay? Good. K equal to 32. Right. But there is one more formula to find the K value. That is, write it method 2. This is method 1 you consider, for example. This is method 1. You consider method 1. Next, there is one more formula to find the K. So, that is method 2, for example. Method 2. K equal to product of lengths. Product of lengths. Product of lengths from the point to pole. From point to poles. Product of lengths from point to poles. From point to poles divided by product of lengths from point to 0. Product of lengths from point to poles divided by product of lengths from point to zeros. Product of lengths from point to poles divided by product of lengths from point to zeros. This is the one more formula. So how to find here? In case no zeros, denominator 1. In case no poles, numerator is 1. Okay. So what is the transfer function tell here? G of S, H of S equal to what we selected? k by s into s plus 8. So what is the point? Tell. What is the point we selected? S equal to what? Minus 4 plus j4 we selected. Okay, now represent the poles and zeros in the S plane. Minus 4 here. So this is minus 4, this is j4. This is the point. This is the point. Minus 4 plus j4. Now we have to find the length here. We have to find the length. Length you have to find. So what is this length? Tell. What is this length? You have to find this length. And we have to find this length. These two lengths you have to find. What is this distance? Tell. What is the distance? 4. What is the distance? Tell. 4. Yes or no? This is 4 only, no? This is 4 only, no? 4, 4. What is this diagonal distance? Root of, bolo, a square plus b square. So that means 4 square plus again 4 square. That means what? 16 plus 16, root 32. Root 32. Here also, what is the distance? 4. What is the distance? 4. What is the diagonal distance? Root of 4 square plus 4 square. That equal to what? Root 32. Root 32. So this is also root 32. This is root 32. So now tell product of lengths from point to pole. This point, this is point P, for example. P to pole, point to pole. How much? Tell. Root 32. Divided into, if how many poles? Only 2 poles are there. So point to pole, root 32. Point to pole, how much? Again, root 32. Divided by, is there any zeros here? Is there any zeros? No zeros, means denominator 1. So what is the answer? 32. If length is known, the second formula is very easy. If length is known, use the second formula. If length is not known, use the first formula. Length known, use the second formula. Length is case not known, use the what? First formula, magnitude condition. Both the answers are same. That's all. It is a magnitude and angle condition. Okay, that's all. Next, we'll start the construction rules. We'll start the construction rules. Construction rules of root locus. Construction rules of root locus. Construction rules of root locus. See, in the root locus, any question comes means 70% based on rules only. If you are perfect, if you are perfect in rules, total 8 rules, all the rules, if you are perfect, then 90% of the problems in the root locus you can solve. No doubt. More than 90% you can solve, no doubt. So rules are very, very important. Listen carefully. Okay, na? Okay, na? Sorry, listen. First, rule 1. Symmetrical. Symmetrical. What is symmetrical? Symmetrical. What is symmetrical? Root locus diagram is symmetrical about the real axis. Root locus diagram is symmetrical. Root locus diagram is symmetrical about real axis. Root locus diagram is symmetrical about real axis. Why it is symmetrical about real axis? Why the root locus diagram is symmetrical about the real axis? Anybody? Why it is symmetrical about the real axis? Anybody? Anybody? Nobody? Because the location of the poles and zeros are symmetrical about the real axis. Because the location of poles and zeros, the location of poles and zeros, in the S-plane, because the location of poles and zeros in the S-plane are symmetrical about the real axis. Are symmetrical about the real axis. The location of the poles and zeros are symmetrical about the real axis. Root locus, the correct root locus diagram is the one, it should be always symmetrical about the real axis. Listen, all of you. For example, you take any transfer function. You take any transfer function. This is J omega. So if you take any transfer function, where are the poles and zeros tell? The poles may be at origin. The pole may be in the left of the S-plane on the real axis, or there may be zeros on the real axis, or there may be complex conjugate poles like this. Complex conjugate means it should be a pair of the poles. It is not a single pole. Or there may be what? A zeros on the imaginary axis. Zeros on imaginary means single zero not possible. It is a pair of zero. Single zero we cannot design, we cannot implement also. It is not possible single imaginary, it is not possible single real. So a single complex conjugate also not possible. So pair of the poles or pair of the zeros, or there may be complex conjugate zeros like this. Complex conjugate zeros like this. Complex conjugate pair of the zeros or pair of the poles. So you observe here what happened. All the poles and zeros, how it is tell? All the poles and zeros, how it is tell? It is symmetrical about the real axis. If fold with respect to real axis, just fold it. If fold with respect to real axis, the upper part of the poles and zeros coincide with lower part. Upper part of the poles and zeros coincide with lower part. Upper part coincide with what? Lower part. That's why the root locus diagram is symmetrical about the real axis. The correct root locus diagram is the one. It should be symmetrical about the real axis. You take any transfer function, whatever you want to take, and represent the poles and zeros. And observe, you fold it, observe with respect to real axis, which are symmetrical about the what? Real axis. That's why root locus diagram is symmetrical about the real axis. But we are not taking any special poles, special zeros. We are not taking any special pole. We are not taking any special zero for root locus diagram. To the same poles and zeros, we'll draw a root locus, Bordeaux plots, Nyquist plots. That means all the plots must be symmetrical about real axis. To the same poles and zeros, we can draw Bordeaux plot. To the same poles and zeros, we can draw the Nyquist plot. That means all the plots must be symmetrical about real axis, but not. Why? Because Symmetry not only depends on poles and zeros location. Symmetry depends on graph sheet also. Root locus diagram drawn on where? Graph sheet, normal graph sheet. Root locus diagram drawn on normal graph sheet. Just graph sheet malum na, normal graph sheet. Root locus diagram drawn on normal graph sheet like this. We'll draw on normal graph sheet. Root locus diagram drawn on normal graph sheet. So what happened here in this graph? This graph is symmetrical about the midpoint or not? So graph also symmetrical, poles and zeros also symmetrical. That's why root locus diagram is symmetrical about the real axis. If you take border plot drawn on where? Semilog sheet. Border plot drawn on semilog sheet. Semilog sheet, which is linear or non-linear. It is not symmetric about origin. Even it is non-linear. That's why border plots are not symmetrical about the what? Real axis. Graph is not symmetric about origin. So logarithmic scale non-linear. So that's why border plots are not symmetrical about the what? Real axis. When you go for Nyquist plot drawn on polar plots. Nyquist plot constructed based on polar graph sheet. How the polar graph sheet tell? It will be there like this. Polar graph sheet is like this. Like this is there, polar graph sheet. Like this circle. So is it symmetric about origin or not? Is it symmetric about origin or not? Yes, that's why Nyquist plots also symmetrical about the real axis. Root locus diagrams, Nyquist plots symmetrical about the real, because the plot also symmetric about origin. Poles and zeros also symmetric about the real axis. That's why the root locus diagram, Nyquist plots, both are symmetrical about the real axis, but not the border plot. Write that word. Write that word. Write that word. The symmetry not only depends on poles and zero location. The symmetry not only depends on poles and zero location. It depends on graph sheet also. It depends on graph sheet also. Graph sheet also, on which the plot is constructed. It depends on graph sheet also. Nyquist plot also symmetrical about real axis. Nyquist plots also symmetric about real axis. Symmetric about real axis, but not border plot. But not border plot. Because border plot drawn on non-linear graph sheet. Because border plot drawn on non-linear graph sheet. Border plot drawn on non-linear graph sheet. Okay, but be remember first statement, the root locus final, all these are just for explanation. What you have to remember? You have to remember that the root locus diagram is always symmetrical about the real axis. That's all. Okay, na? Okay, na? Next, second rule. Rule 2. Rule 2. Number of root locus branches. Number of loci. Number of loci. Loci means root locus branches. Root locus. Number of root locus branches. Sometimes separate loci enter. Separate. Separate loci. Separate loci. Separate root locus branches. It completely depends on number of poles and zeros. Number of root locus branches depends on number of poles and zeros. Number of root locus branches depends on number of poles and zeros. Case 1. Poles greater than 0 in case number of root locus branches equal to number of poles. In case poles are greater than 0, number of root locus branches equal to number of poles. Case 2. Poles less than 0. Number of root locus branches equal to number of zeros. Whatever is large, that will get it. Poles are greater, we will get the poles. Zeros are greater, we will get the zeros. Finally, number of poles equal to number of zeros only. I told it already. Finally, number of poles equal to number of zeros because branch start at pole, end at what? 0. For one pole required what? 1 0. For each and every pole required 1 0. So that means number of poles must be equal to number of zeros. So this is the second one. Next, third rule. Third rule is very, very important. Third one is very, very important. Real third, fourth, fifth, sixth. These are very, very important. Third, fourth, fifth, sixth are very, very important. Third rule is real axis root locus branches. You have to remember all these rules are real axis root locus branches. Real axis root locus branches. Right. Listen, all of you. Listen, all of you. A point lies on root locus branch means listen. A point lies on root locus branch means, for example, I'll select some poles. Here one pole, here one pole, here one pole, here 1 0. Some poles and zeros. Just listen. I selected some poles and zeros on the real axis. Select a point on the real axis. Just select the point. I selected point here. Select a point. Count the sum of the poles and zeros to the right hand side of that point. Just count it. P plus Z you count. Just count the sum of the poles and zeros to the right hand side of that point. To the right hand side of that point. P plus Z to the right hand side of that point you count. In case it is odd, If you count it, P plus Z is odd, then there exists a root locus branch. Then there exists the root locus branch. Root locus branch. Root locus branch. You just take a point, count right. Just take a point, count right. In case it is odd, then there exists a root locus branch. In case it is odd, then there exists a root locus branch. That's all. If it is odd, then there exists a root locus branch. For example, take a point, count right here. You take a point, count right. Come on. Take a point, count right. Take a point here, count right. Odd or even? P plus Z, odd or even? P plus Z. 0, na? 0 is even. No pole, no 0 is the right of this point. How many poles? No pole. How many zeros? No 0. That means P plus Z is 0. 0 means even. Even means no root locus. Means here P plus Z is even. Even means no root locus. No root locus. Now take a point, count right. Come on. Here P plus Z right side how much? 1 pole, na? P plus Z is 1. That means odd. Odd means there exists the root locus. Here P plus Z 1, na? Right side 1. Here count it 1 pole. So odd. Odd means there exists the root locus. Here odd. There exists root locus. Take a point, count right here. 1, 2 means 2. 2 means even. Just count right. Count right only. How many? 1 plus 1, 2. So 2 means even. Even means what? No root locus. No root locus. But don't take exact point on the pole or 0. You should not select the point on exact location of pole. You should not select a point on exact location of pole as well as exact location of 0. You should not select it on exact location of pole or exact location of zeros. By default, each and every pole, your 0 lies on root locus only. Poles and zeros always lies on root locus only. Why? Because why poles and zeros always on root locus means root locus branch start at where poles only. Root locus branch end at where zeros only. That means poles and zeros by default on root locus branch. So next take a point here, count 1, 2, 3, odd. Odd means there exists the root locus. Take a point, count right. 1, 2, 3, 4. 4 means even. Even means what? No root locus. No root locus. That's all. What is the meaning of root locus? Tell anybody. What is the meaning of root locus? Root locus means what? Anybody? Root locus means what? Anybody? Root locus means, root locus exist means, root locus exist means path exist. Root locus exist means path exist. Path for closed loop poles exist. Path for closed loop poles exist. Root locus exist means path exist for closed loop poles. Path exist for closed loop poles. Root locus exist means path exist for closed loop poles. No root locus means no path. No root locus means no path exists for closed loop poles. No path exists for closed loop poles. No path exists for closed loop poles. So path exist here exist. Path exists for closed loop poles. One minute. Root locus exist means path exist. For closed loop poles. No root locus means no path exists for closed loop also. So the pole should move only on the path. When path is there, then only pole should move. If no path, pole should not move. Now listen here, all of you listen here. Here there exists the what? Root locus branch. Here there exists the root locus branch. I'll make it dark. So this is root locus branch. Here no root locus. Here also there exists the what? Root locus branch. Here also there exists root locus branch. Okay. Okay. Here also exists root locus branch. Next, now listen. Listen, Bhaiya. So here, listen. So as K increase, here what is the K value at pole? What is the K value at pole? Anybody? K value at pole is 0. Here K is 0. I already told in the last day. At poles K 0. At poles K equal to 0. Here also what is the K value? 0. Here what is the K value? Infinity. At 0 what is the K value? Plus or minus infinity. But default is plus infinity only. Default is plus infinity. Default is plus infinity. Now listen. All of you listen. Listen, Bhaiya. If you listen, then only you will get it. Listen. So if you listen. Now K increases. If K will increase the K. Where this pole moves? Where this pole moves? Right or left? Where this pole? Pole at origin moves right or left? It moves right or left? Anybody? Right or left? It moves only left. Why? Because right side no path. Here no path. It cannot move right. So it has to move only left side only because it should move only on root locus branch. This pole, it cannot move to right because no path. It cannot move to left. Sorry. It cannot move to left. It has to move right only because left side no path. It has to move only right only. It should move right. This pole, it cannot move right. It has to move only left like this. It has to move only left only. Then what happened? And no pole should move this side also because no path. No pole should move this side also. Then what happened? Tell, as K increases, this pole go on moves to left. This pole go on moves to left and occupies the what? Zeros. As K increases, this pole go on moves to left and occupies the what? Zeros. These two poles, what happened? Both are moving opposite direction. Both move opposite direction. Both will collide. Both will collide. Once it collides, it leaves the real axis. Once it collides, it leaves the what? Real axis. That rule will come later. That is called the break point. Once it both are coming opposite direction. Opposite direction means collide. Both are coming opposite direction means collide. Once collide, it leaves with some angle. That will come later. That will come later. But here what happened? This pole go on, moves left, occupies the 0. Once the pole occupies the 0, once the pole occupies the 0, then we can say it is a complete root locus branch. It is a complete root locus branch. Root locus branch. When K increased from 0 to infinity. When K increased from 0 to infinity. It is a complete branch. Complete root locus branch when K increased from 0 to infinity. It is complete root locus branch when K increased from 0 to infinity. So once pole occupies the 0, then we can say complete branch. Here is the pole occupies 0 in this case? No, that means it is not a complete root locus branch. If all the poles occupies the 0, then we can say complete root locus diagram. If all the poles reaches the 0, then we can say it is a complete root locus diagram. It is a complete root locus diagram. All the poles reaches all the zeros, then only we can say it is a complete root locus diagram. Complete root locus diagram. Here, these two poles not occupies 0. The pole at origin, the pole at some point not reaches the 0. So we cannot say it is a complete root locus diagram. A complete root locus branches. This is one branch. Each pole one branch. 3 poles, 3 branch. This is complete branch, but this is not complete branch. This is also not complete branch. Whatever it is, what is the final conclusion? The pole should move only on the root locus branch. The pole should move only on root locus branch. Pole should not move on no root locus branch. It should move only on root locus branch. Once the pole occupies the 0, then we can say it is a complete root locus branch. Once the pole occupies the 0, then we can say it is complete root locus branch. Okay, na? What is the how to identify either lies on the root locus or not means the sum of the poles and zeros to the right hand side of that point should be odd. A point should lies on root locus. The sum of the poles and zeros to the right hand side of that point should be odd. Then there exists the what? Root locus branch. So write the statement. What is the statement? A point to lie. A point to lie on root locus branch the sum of poles and zeros, the sum of poles and zeros to the right hand side of that point, a point to lie on root locus branch, the sum of poles and zeros to the right hand side of that point, to the right hand side of that point should be odd. To the right hand side of that point should be odd. A point to lie on root locus branch, the sum of poles and zeros to the right hand side of that point should be odd. Okay, this is the rule. And one more thing, one more point, what I told, the pole should move only on the root locus branch. The poles should move only on root locus branches. Only on root locus branches. The pole should move only on root locus branches. Okay, once the pole occupies the 0, once the pole occupies the 0, then it is called complete root locus branch. Complete root locus branch. When k increase from 0 to infinity. So these are the statements. Okay. So note down one problem. Identify the real axis root locus branches. Identify the real axis root locus branches. Identify the real axis root locus branches for the system. G of S, H of S equal to K into S plus 1, S plus 3, S into S plus 2 into S plus 1. Come on, do it. Represent the poles and zeros in the S-plane, all of you. Represent the poles and zeros, all of you. One pole at origin, 1 0 at -1, one pole at -2, 1 0 at -3, one pole at -5. Now identify the root locus branches. Take a point here, right side, no pole and 0. 0 means no root locus. Take a point here, right is 1. 1 means root locus. Take a point, count right 2. 2 means no root locus. Take a point, count right 3. 3 means root locus. Take a point, count right 4. 4 means no root locus. Take a point, count right 5. 5 means root locus. So now as k increases, simply this pole moves towards the, here what is the value of k? 0. At this pole, k equal to 0. At this pole, what is k? Infinity. At this pole, k 0. At this pole, k infinity. At this 0, k infinity. At this pole, k 0. What happens as k increases? This pole moves toward the left and it occupies the what? 0. That's all. No pole can move this side. Pole should not move right because right side no branch. This pole also cannot move to right. So here root locus branch exists. It will go on, moves to left and it occupies the what? 0. It occupies the 0. This pole cannot move to right. This pole go on, moves to the left. Then what happened? There is no 0. So it goes to infinity. It goes to infinity. We will assume a 0 at minus infinity. We will assume a 0 at minus infinity. Where k equal to infinity. Where k, this is assumed, not exist. It is assumed. We will assume 0. Assume 0. Assume 0. 0 at minus infinity. So that will give actually angle of asymptote, it will come. So now what happened? All the poles, this pole reach 0, this pole reach 0, this pole reach 0. All the poles reaches the what? All the zeros. Then I can say it is a what? Complete root locus diagram. It is a root locus diagram when k increase from what? 0 to infinity. When k increase from 0 to infinity. It is a root locus diagram when k increase from 0 to infinity. That's all. Okay? Right. We'll take the break. 10 minutes break. After that, we'll continue. Okay. Take the break. Right. Next, one more problem you note down. Next problem. Identify the following points. Next problem. Right. Identify the following points. Identify the following points which lies on root locus branch. Which lies on root locus branch. Identify the following points which lies on root locus branch to the given system. So G of S, H of S equal to K into S square plus 2S plus 2 divided by first point S equal to 0. Second point S equal to -1. Third point S equal to -2. Fourth point S equal to -3. Fifth point S equal to -4. Sixth point S equal to -5. Seventh point S equal to -6. Eighth point S equal to -infinity. Ninth point S equal to -1 plus J1. 10th point S equal to -1 minus. Come on. Come on, which of the points lies on root locus? Which of the points lies on root locus? Come on, tell the answer. First, draw real axis rule. It is not required to apply angle condition. Angle condition is not required. Angle condition not required. Directly we can answer. We can answer directly. Identify the real axis root locus branches first. So here two poles at origin. K equal to 0. Next, one pole at -2. One pole at -4. One pole at -6. And the zeros. -1 plus J1 minus J1. Minus 1 plus R minus J1. Come on. Now which points on the root locus? 0. Is it on root locus or not? Anybody? K infinity, K0, K0. At poles, K always 0. At zeros, K infinity. Come on, answer. Anybody? Come on, it is the first page after the break. Come on. Yes, no, yes, yes, yes. No, yes, yes. Right. First, 0 is on root locus or not on root locus? 0. It is on root locus only. 0 is on root locus. Why? Because root locus branch, where it starts, tell? Where it starts? At poles. Root locus branch should be start at pole, end at where? 0. It starts at k equal to 0. It starts at k, end at k equal to infinity. Branch starting point pole, branch ending point 0. That means all the poles, because root locus branch starting at pole, na? So that means at pole compulsory branch should be there. At 0 compulsory branch should be there. So that means at each and every pole, every 0, there should be a root locus branch. At each and every pole, every 0, there should be a root locus branch, because that are starting and ending points. That are starting and ending points. So each and every pole, every 0 must be on root locus branch. At each and every pole and 0 location. At each and every pole and 0 location. And 0 location. There should be a root locus branch. There should be a root locus branch. At each and every pole and 0 location, there should be a root locus branch. Because root locus branch start at pole. Because root locus branch starts at poles. And end at zeros. So this is a pole. So 2 branches starting. It may not goes to right. It may not goes to left. What happens? As k increases, it may leave the real axis like this. It leaves the real axis. It will go along this imaginary some distance. So, but how many branches starting here? 2 branches starting, because 2 poles are there at origin. 2 branches starting. Where it will go? It will go towards the 0. There is a chance that it may go like this. There is a chance that this may go like this. That depends on the what? Angle of arrival. That will give the last rule. So it may goes like this. That depends on angle of arrival. That will come later. 8th rule. It is the 8th rule. So that means here, is there any root locus branch here? There exists a root locus branch. Here, no root locus branch. Here, no root locus. We take a point 1, 2, 3, 4, no root locus. Here, there exists a root locus branch. Up to where? Minus infinity. Now tell 0 on root locus branch. Minus 1, it is not on root locus branch. At minus 1, no root locus. No root locus branch. Minus 1 plus R minus J1 on root locus. But minus 1 is not on root locus. Year to year, there is no root locus branch. Minus 2, it is on root locus branch. Minus 3, it is on root locus branch. Minus 3, it is here minus 3, no, it is on root locus branch. Minus 4, it is on root locus branch. Minus 5, it is not on root locus. Minus 6, it is on root locus branch. Next, minus 7, minus infinity root locus. Minus 1 plus R minus J1 also on root locus branch. So like this, you have to identify either the point lies on root locus or not. Simple logic, at each and every pole and zero location, there exists the root locus branch because root locus starts at pole, end at zero. Be remember. No need to apply angle condition. Never apply angle condition at the position of poles and zeros. Never apply angle condition at the position of poles and zeros. By default, you have to consider all the poles and zeros on root locus branch, and k value at the poles is 0, k value at infinity is, k value at 0 is infinity. K value at 0 is infinity. Don't apply angle condition also. By default, you have to consider all the poles and zeros lies on the what? Root locus branch. Even no need to apply angle condition. Angle condition when you have to apply, if you are not able to find with this third rule, if you are not able to find by using this real axis root locus branch, then you have to apply the angle condition. For example, if you given a point -2 plus j3 lies on root locus or not, can you find -2 plus j3? It is not possible because that is not a pole location, that is not here a zero location, even that is not real axis, it is a complex point. Then compulsory you have to apply the what? Angle condition. You have to apply angle condition, then you have to check. Then you have to check the given point either lies on root locus or not. That's all. Okay, na? Okay, na? Next one. Next rule, asymptotes. Asymptotes. Rule 4. Asymptotes. Asymptotes are the root locus branches which approach to the infinity. Asymptotes are the root locus branches which are, asymptotes are straight lines, sorry. Asymptotes are straight lines which approach to the infinity. Write that word. Asymptotes are straight lines which approach to the infinity. Asymptotes are straight lines which approach to the infinity. Number of asymptotes n equal to P minus Z. Angle of asymptote theta equal to two q plus 1 into 180 degrees divided by P minus Z, where q equal to 0, 1, 2 and so on, P minus Z minus 1. Theta equal to 2q plus 1 into 180 by P minus Z, where q 0, 1, 2 and so on, P minus Z minus 1. Asymptotes are always symmetrical about the real axis. Asymptotes are always symmetrical about real axis. Asymptotes are always symmetrical about the real axis. Asymptotes gives the direction of zeros. Asymptotes gives the direction of zeros. when the number of poles greater than zeros. Whenever poles are greater than zeros, asymptotes gives the direction of zero. In case poles are less than zero, asymptotes gives the direction of poles. That's all. But generally, proper transfer function, strictly proper transfer function equal to what is the meaning of strictly proper transfer function? Strictly proper transfer function means the number of poles must be greater than zero. Generally, poles are greater. That's why we'll assume zeros at infinity. That infinity direction given by angle of asymptotes. Okay, na? Next, centroid. Next, centroid. We'll solve the problem by combination of these two rules. Centroid, sigma. What is a centroid? It is a intersection point of asymptotes. It is a intersection point of asymptotes on the real axis. It is a intersection point of asymptotes on the real axis. It is a intersection point of asymptotes on the real axis. What is the centroid formula? Sigma equal to sum of real part of poles minus sum of real part of zeros. Divided by P minus Z. Centroid equal to sum of real part of poles minus sum of real part of zeros divided by P minus Z. Centroid may be located anywhere on the real axis. Centroid may be located anywhere on the real axis. It may or may not be on root locus branch. It may or may not be on root locus branches. Centroid may be located anywhere on the real axis. It may or may not be on root locus branches. That's all. Now we'll solve the problems. Right. Calculate the right. Right. Next. Note on the problem. Calculate the angle of asymptotes and centroid. Calculate the angle of asymptotes and centroid for G of S, H of S equal to K by S into S plus 5 into S plus 10. Come on, do it. First, now use all the 5 rules. Come on, root locus is symmetrical. Leave that. First rule is leave it. Second rule, number of root locus branches. Number of, first rule symmetrical, R1 symmetrical, that you know it. R1 symmetrical. By default, will get symmetrical. No need to think about that. Rule 2, number of loci bolo. Number of loci, root locus branches. How many branches? Poles are greater than zeros, na? So that means number of poles. That equal to how many? 3. Third rule, come on. Rule 3. Identify the real axis root locus branches. That we can do later. Next, rule 4, you do it. Rule 4, you do it. Rule 3 will end. Rule 3 will draw later. Rule 4, you do it. Asymptotes. How many number of asymptotes? N equal to number of asymptotes. Bolo, number of asymptotes. How many? N equal to P minus Z. So what is P? 3. What is Z? 0. So that means number of asymptotes equal to what? 3. Number of asymptotes is 3. Next, angle of asymptotes. Angle of asymptotes. Come on, what are the angle of asymptotes? Theta. 2q plus 1 into 180 by P minus Z. What is the first value of Q? Q, what? Q equal to 0, 1, 2, and so on. P minus Z minus 1. What is P here? 3. Z what? 0. Minus 1 means up to 2 you have to consider. Means you have to consider Q 0, 1, 2. Up to 2 you have to consider. If you Q 0, what is angle of asymptote? Tell. If you Q 0, what is angle of asymptote? 180 by P minus Z. Q 0 means 180 by P minus Z. What is P minus Z? 3. That means what is the angle? Angle of asymptote is 60 degrees. Next Q1, you substitute Q1, get the answer. Q2, get the answer. But simple logic is, listen. When Q equal to 0, what you are getting? Listen, Bhaiya. When Q equal to 0, what you got? 180 by P minus Z. 180 by P minus Z. When Q equal to 0, first angle you always calculate. Or use always 180 by P minus Z. To calculate angle of asymptotes, use 180 by P minus Z. Just remember 180 by P minus Z. P minus Z, by looking the problem, we can identify. What is the P minus Z? 3. So P minus Z, by using the problem itself, we can identify 3. 180 by 3 means what? 60 degrees. 180 by 3 means 60. Multiply with odd number. 60 into 1, 60 into 3, 60 into 5. Just multiply with odd number. 60 into 1, 60 into 3, 60 into 5. Just multiply. Multiply with odd number. Directly will get the answer. Multiply with odd number. 60 into 1, how much? 60. 60 into 3, how much? 180. 60 into 5, how much? 300. Get the first angle. Just to get the first angle. 180 by P minus Z use. 180 by P minus Z use. Then get the first angle. We got 60. 60 into 1. Next, multiply with odd numbers. Multiply with odd number. 60 into 1, 60 into 3, 60 into 5. How many angles required? P minus Z. Number of angles required equal to P minus Z. 3 angles. So we got 3 angles. Number of angles required equal to P minus Z. That's all. Next, rule 5, centroid. Sum of real part of the poles. What are the real part of the poles? -5, -10. minus real part of the zeros 0 divided by p minus z is 3. That means how much? Minus 5. Centroid is minus 5. Now draw the diagram. Now draw the diagram. Draw the root locus diagram. Okay? Draw the root locus diagram. Okay? Draw it. Come on, draw it. Draw the root locus diagram. So one pole at origin, S equal to 0, K equal to 0. This is J omega. Next, one pole at what? Minus 5 and minus 10. One pole is minus 5. K equal to 0. Minus 1. Another pole is minus 10. K equal to 0. Now identify the real axis root locus branches. Take a point, count right. How many? 0 means no root locus. No root locus. Take a point, count right. How many? 1. 1 means there exists a root locus. Take a point, count right. 1, 2. Even. Even means no root locus. Take a point, count right. 1, 2, 3. 3 means odd. There exists root locus. So now make it dark. Root locus means make it dark. That's all. Root locus means make it dark. Root locus means make it dark. That's all. Now represent the centroid. What is the purpose of centroid? Centroid required to draw the angle of asymptotes. Centroid is required to draw angle of asymptote. Centroid is required to draw angle of asymptotes. To draw the angle of asymptotes. Angle of asymptotes. Centroid is required to draw the angle of asymptotes. So in case no asymptotes are there, centroid is not required. No need to calculate centroid. Centroid required to calculate when angle of asymptotes are more than 1. It will come later. So now come on, draw it. Now draw the diagram. Now draw it. Centroid. What is the centroid? You got it? Minus 5. Centroid minus 5. So this is the centroid. Centroid is minus 5. With respect to centroid, what you have to draw? 60 degrees, 180 degrees, 300 degrees. With respect to centroid, 0 degrees. This is 0 degrees. You have to draw 60 degrees, 180 degrees, and 300 degrees. Draw the 60 degrees. You draw the 60 degrees. So this is 60 degrees. Draw a line of 60 degrees, for example. Next, 180 degrees. This is 180 degrees. This is 180 degrees. This is 180 degrees. This is 60 degrees. 60 degrees. Next, 300 degrees. Degrees. This is 300 degrees. So that means what I told, angle of asymptotes. What I told, actually we should put the dots because these are the infinite points. Like this, put the dots actually. But we are not drawing on the semilog sheet. We are not drawing on the graph sheet. Now white paper only we are drawing. For objective type, white paper is enough. But conventional paper, IES conventional you are writing means you have to draw on the graph sheet. So I can put it 0 here because it is not a graph. It is a white paper. Instead of putting like this dots and writing minus infinity, what I will do? I'll put the 0. I'll put the 0 at minus infinity. I'll write. This is also 0 at k equal to infinity. This is 0 at k equal to infinity. That means these are the infinite points. This is 0 at k equal to infinity. That means along 60 degrees at infinity, there is a 0. Along 180 degrees at minus infinity, there is a 0. Along 300 degrees at infinity, there is 1 0. Asymptotes gives the what? Direction of zeros. Asymptotes gives the direction of zeros. So now how many asymptotes here? 3 asymptotes. So 3 zeros. And count the poles. How many poles? 1, 2, 3. 3 poles. Once you represent, listen, once you represent angle of asymptotes, then the number of poles must be equal to number of zeros. After representation of asymptotes, the number of poles must be equal to number of zeros. The number of poles must be equal to number of zeros. The number of poles must be equal to number of zeros. So how many poles are there here? Count. Number of poles, you count it. How many? 3 poles. How many zeros are there? 3 zeros. 1, 2, 3 poles. Zeros 1, 2, 3. 3 zeros. So after asymptotes, always you check it. The number of poles must be equal to number of zeros because branch start at pole, end at zeros. Now you have to draw the root locus diagram. So drawing the root locus diagram is nothing but identification of path from pole to 0. Drawing the root locus diagram is nothing but identification of path from pole to 0. Identification of path from pole to 0. So what happened here? So here direct path is there from pole to 0. So that means I can draw direct root locus. As k increases, this pole cannot move to right. It has to move to only left. It will go on, moves to left. It occupies the 0 when k equal to infinity. So one pole gone. One pole occupies the 0. One pole gone. One pole, 1 0 completed. This is complete branch. One pole, 1 0. Next, how many poles? 2 poles and 2 zeros are there. Next, 2 poles and 2 zeros are there. 2 poles are there, 2 zeros are there. Now, as k increases, this pole cannot move to left. This pole cannot move to right. This pole cannot move to right because this side no branch, this side no branch. As k increases, these 2 poles should move opposite direction. So these 2 poles moves on root locus branch. Both will move in opposite direction. Then both will collide. Once collide, it should leave with an angle of plus or minus 180 degrees divided by n. Once poles collide, it should leave the real axis. Once the poles collide, it should lose the real axis. So it leaves by maintaining the angle of plus or minus 180 degrees divided by n, where n is number of poles meet at that point. Number of poles collide or number of poles meet at that point. How many poles meet? 2 poles. That means plus or minus 90. So number of poles meet at that point. It will come in the break, the next rule. In the 6th rule, it will come about 180 by n. So it leaves with plus or minus 90. One pole with plus 90, another pole with minus 90, it leaves. It belongs to next rule. It will come, no need to worry. 180 by n, it will come. So then, once leave with plus or minus 90, where it will go? Where it will go? This pole should move near to asymptote. This pole moves near to asymptote. The pole should move near to 0, na? Near to asymptote, parallel to asymptote, enter into asymptote, occupies the 0. The pole moves near to asymptote, parallel to asymptote, enter into asymptote, occupies the 0. And this pole also same. Near to asymptote, parallel to asymptote, near to asymptote, parallel to asymptote, near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros. Near to asymptote, the pole should move. The pole should move near to asymptote. parallel to asymptote, enter into asymptote and occupies the zeros. It should move near to asymptote, parallel to asymptote, enter into asymptote and occupies the zeros like this. So pole moves like this. Near, parallel, enter, occupies the zeros. Near, parallel, enter, occupies the. That's all. It is a root locus diagram. Now fold with respect to real axis. It is symmetric about the what? Real axis. You fold it, upper part will coincide lower part. Now check it, this pole reaches this zero, this pole reaches 1 0, this pole reaches the another 0. All the three poles reaches 3 zeros. So this is called complete root locus diagram. This is called the complete root locus diagram. Okay, na? Right. Next one. Next problem. Next problem. Come on, repeat the above problem. For g of s, h of s equal to k into s plus 10 by s square into s plus 1. Come on, do it. Come on, Guruji, come on. Come on. So find it. Number of asymptotes. Number of asymptotes. Number of root locus branches, how many? So P minus Z. Here P greater than Z. Number of root locus branches is 3. Because P is greater. Number of asymptotes. Number of asymptotes. N equal to P minus Z. So 3 minus 1. 3 poles and 1 0. That means 2. Angle of asymptotes. What is the formula I told? Simply 180 by P minus Z. Remember original formula 2q plus 1 180 by P minus Z. But calculations use 180 by P minus Z. P minus Z is 2. So 180 by 2 is 90. Multiply with odd number. 90 into 1, 90 into 3. Only 2 angles required because P minus Z is 2 angles. So 90 into 3 means 270. Next centroid. Sigma. Centroid find. Sum of real part of pole -1 minus real part of zeros -10 divided by P minus Z is 2. So that means what you are getting? -1 plus 10 by 2. So plus 4.5. Now draw the root locus diagram. Two poles. One pole at -1. 1 0 at -10. K0. K infinity. S0. K0. Come on. Identify the root locus branches here. Identify the root locus branches. Is there any root locus branch here? No. There is no root locus branch here. P minus Z 0. Is there any root locus branch here? No, because 2 poles at origin. 2 poles na? No. So here 1, 2, 3. That means here there exists a root locus branch. Here exists root locus branch. Next, centroid. What is the centroid? Tell here. Centroid is plus 4.5 somewhere here. Centroid. Angle of asymptotes. What is the angle of asymptote? Tell. One is 90, another one is 90, another one 270. One asymptote along 90. That means along 90 there exists 1 0, where K is infinity. Another one along 270 there exists a 0, where K equal to infinity. Now tell. Now draw the root locus diagram. So now also count the number of poles. 2 plus 1, 3 poles. Count the number of zeros. 1, 2, 3, 3 zeros. Once represent the asymptotes, the number of poles must be equal to number of zeros. Now draw the diagram. As K increases, this pole moves toward the left. It will go on, moves toward the left. Then it occupies the 0 when K equal to infinity. It occupies 0 when K equal to infinity. One pole completed. Next, these two poles, it cannot move to right, it cannot move to left. Because right side branch is there, left side branch is there. As K increases, it should leave the real axis. It leaves the real axis with plus or minus what? 90 degrees. So poles are leaving the real axis means it should be counted with plus or minus 180 by n. How many poles leaving? 2 poles are leaving. That means it leaves with plus or minus 90. So one pole with plus 90, another pole with minus 90. So this is leaving with plus 90, one pole leaving with minus 90. Then where it will go? One pole moves towards 1 0 like this. One pole moves towards 0 like this. And then it enters into asymptote and occupies the zeros. Poles always moves towards the 0. It moves near to asymptote, enter into asymptote and occupies the 0. This pole also same. Near to asymptote, enter into asymptote and occupies the zeros. Near to asymptote. It moves near to asymptote, parallel to asymptote, enter into asymptote and occupies the what? Zeros. So that's all. So all the poles reaches what? All the zeros. Root locus diagram what? Symmetrical about the what? Real axis. Root locus diagram is symmetrical about the real axis and all the poles reaches all the zeros. So like this, you have to draw the root locus diagrams. These are approximate root locus diagrams. Exact means you have to draw on the graph sheet. Exact points you have to represent, and then you have to draw on the graph sheet. Next rule. Rule number 6. Break point. It is a very important rule. Break point. Break point. Break point means simply junction of poles. Break point means simply junction of poles. It is a junction of poles. Two or more poles lies at any location. Two or more poles meet. Two or more poles directly locate at any location. Then it is called a break point. Write it. The point at which break point means the point at which two or more poles meet. Or two or more poles meet. Or two or more poles directly locate at any location. At any location, then it is called break point. Then it is called break. Two or more poles meet or directly locate at any location, then it is called break point. So actually here, strictly speak, there is no breakaway break-in point. Simply we can call it as break points. But some books, they unnecessarily classified. If you see standard book like Benjamin Chico, they don't classify breakaway point and break-in point, because all the most of the break points act as a breakaway as well as break-in. So first of all, what is the breakaway point? What is the break-in point? Next, breakaway point. Breakaway point. What is the breakaway point? The point at which the root locus branches move away from the point. The point at which the root locus branches moving away from the point. The root locus branches moving away from the point is called breakaway point. BAP means breakaway point. Breakaway point. This is actual correct definition. But some books, especially some local author books, to make it very easy, what is the breakaway point they given? The point at which the root locus branches leaving the real axis they given. Leaving the real axis. The point at which the root locus branches leaving the real axis is called breakaway point. The point at which root locus branches Root locus branches means poles only. Root locus branches leaving the real axis. Leaving the real axis is called breakaway point. Actually, this is the second local author definition. Actually, correct definition is first one only. But some books they given leaving the real axis. It is not compulsory that always the poles leaves the real axis. For example, see here, this is a breakaway point because as k increases, both the poles move opposite direction, collide, then leaving the real axis here, leaving the real axis, leaving the real axis or moving away from the point also. Both are same, moving away from the point. It's called, it is a breakaway point. Actually, it is break in and break away. It is having break in and break away. Why? Because listen, all of you listen. First, I'll write the definition actually. So, the point at which root locus branches moving away from the point. For example, see, I'll take the two poles, one pole at origin. I'll take one pole at -2 or some point, whatever it is. So, here as k increase, so what happened? Here root locus branch not exist here. Root locus branches exist here. So as k increases, what happened? Both the poles are moving opposite. Then at some point both will meet. After meeting, then it is leaving, moving away from the point, moving away or leaving the real axis. So then it is called the what? Breakaway point. It is correct. Moving away from the point or leaving the real axis. It is a breakaway point. 100% correct. But in case it is not leaving the real axis, I'll take one more case. For example, I'll take, for example, two poles I'll take here. 1, 0 I'll take here. 1, 0 I'll take here. So now what happened here? This is -1 I'll take. This is -2 I'll take. This is 0 I'll take. Is there root locus branch here? Tell. Exist. Root locus branches exist. Here also root locus branches exist because here two poles na root locus branch exists. Here k equal to 0. Here k equal to infinity. Here k equal to infinity. So what happened? Tell. What is that -1? Tell. It is not living, no doubt. Two poles are meeting means it is 100% break point, no doubt. You find dk by ds. It will come in the next class how to find location of break point. It is 100% break point only. It is 100% break point. So, but it is not leaving the real axis. As k increases, one pole moves towards the origin, one pole moves towards the -2. So these two poles not leaving the real axis. According to this local author definition, it is not at all a break point, but it is a break point. So that means what happened? Even there are the questions. The breakaway point is like that. Most of the break points act as a breakaway and break in. For example, this is break in and breakaway. Why? Because first one pole at origin, one pole at -2. As k increases, these two poles are enter into the point. First entering na. Here what happened? Both the poles entering into point means it is like break-in point. After some time again leaving from the point. Moving away from the point means breakaway point. That means most of the break points act as break-in and breakaway. First enter into the point means break-in. Then after that, moving away from the point means breakaway. That means here break-in is there, breakaway is there. But according to local author, they'll say it is only breakaway point. That is the problem. Standard books, if you say, they'll say it is a break-in and breakaway point. How to answer means you should, based on the option, you should decide. You should decide which is the correct answer based on the options. I'll tell how to decide. So here what happens, strictly speak, here what happened, it is not leaving the real axis, but moving away from the point. Two poles are there at -1. As k increase, both are moving away from the point. That means it is just like what? breakaway point. It is just like breakaway point. It is a breakaway point. Okay, na? So breakaway point means the point at which root locus branches moving away from the point is called breakaway point. What is the break-in point? Break-in point means the point at which root locus branches enter into the point. Is called break-in point. But in local author books, they will give the root locus branches enter into the point is called break-in point. Break-in point means the point at which root locus branches enter into the real axis. The point at which root locus branches enter into real axis. Is called break-in point. One way the second statement is part of the first statement, that's all. I'm not telling second statement is wrong. So second statement is a part of the first statement. So for example, but it's not a complete statement, that's why I'm telling. So here, if we see for example, break-in point. So for example here, I'll take 2 poles here and I'll take 2 zeros here. 2 zeros here. What happened here? There exists a root locus branch here. There exists a root locus branch here. Here there exists a root locus branch. So what happened? Tell. As k increases, these 2 poles move opposite direction. Then both will meet at the point, enter into the point. That means first it is like what? Break-in point. Enter into the point. Here they both are enter into the point. That means it is like break-in point. It is like break-in point. First break-in only. It is like break-in point. After entering, again it leaves the real axis. That means then it will become what? Breakaway point. Then once it leaves, where the pole should move? Towards the what? Left. It should move towards the zeros. No? It will move. It will enter at the midpoint or somewhere in the zeros. Middle of the zero. Because pole should move towards the zeros. It will enter. It will come. Next classes, it will come. So it will enter. That means what is this point? What is this point? It is called break-in. Enter into real axis. Enter into real axis. That means it is called break-in point. According to second definition, this is only break point. According to first definition, this is also break-in point. This is also break-in point. After entering, again it leaves from that point. One pole moves towards 1 0. Another pole moves towards another 0. That means what? Here after entering, again it is moving away from the point. That means again breakaway point. Here also this is what? Break-in point. This is what? Breakaway point. This is breakaway point. That means what? Most of the break points act as break-in as well as breakaway point. How to identify the correct answer means I'll discuss in the next class. How to identify the correct answer I'll discuss in the next class. But be remember the definitions. Break-in means enter into the point. Enter into the point. Enter into the point is called break-in point. Moving away from the point is called breakaway point. Okay, na? So tomorrow I'll continue how to find the location of break points. and the procedures and everything we'll discuss tomorrow. So now today I will close it. If you have any doubt, you can ask it. Okay. Sri Ram. Sri Ram. Sri Ram Gautam. Sri Ram Gautam. Sri Charan.
Hello, sir.
Tell.
11 of sir, page number.
Tell.
Sir, here k equal to infinity can join to -2 also, no, sir?
-2 na. -2 pole na.
Yes, sir. It is 0, no, sir.
What is there? Pole or 0?
Pole only, sir.
How can you join?
K equal to infinity, it is 0, no, sir. -1 plus J1.
-1 plus R J1, that is complex poles na.
Yes, sir.
Which one you have to join?
I'm telling that we can join -2 to -1 plus J1.
Directly we cannot. The root locus diagram should be symmetrical na.
Okay.
How can you join single pole? If you join like this, then what about this 0?
It is symmetrical and this also.
It should be symmetric na. It is not possible.
Yes, sir. Okay, sir.
Next. Karthik.
Hello, sir.
Tell.
Sir, is breakaway and break-in points always on the real axis?
No, it may be even complex also. It will come in the next classes. Okay.
Okay, sir. Thank you. Yes, sir. Thank you.
Abdul.
సార్ మనం ఇక్కడ పోల్స్ 3 జీరోస్ 3 ఎలా తీసుకున్నాం సార్? అంటే ఈ ప్రాబ్లంలో
వేర్
అంటే మీరు ఇక్కడ రూట్ లోకస్ పోల్స్ 3 ఇక్కడ
దిస్ ఇస్ నాట్ కంప్లీట్ రూట్ లోకస్ డయాగ్రామ్.
ఇందాక వేరే ప్రాబ్లంలో చెప్పారు కదా సార్ పెద్దగా.
I told last day also. Remember the page number.
15 14 or 15.
Tell.
ఇది ఎలా తీసుకుంటాం సార్? ఇది 3 ఎలా వస్తుంది?
Asymptotes calculated na. How many asymptotes are there here?
3.
What are the angles?
Angles 60, 180, 300.
What are that points? It is zeros only na.
0 points.
That's all.
ఓకే. అంటే మనం యాంగిల్ ఆఫ్ 0 నే తీసుకుంటామా సార్? అంటే ఆ యాంగిల్ తీసుకోమా మనం?
Poles greater means it is a angle of zeros only.
ఓకే. అంటే 60 degrees ఆ యాంగిల్ 0 దగ్గరే తీసుకుంటాం.
Yes.
ఓకే సార్. అంటే ఇప్పుడు మనకి ఇండికేషన్ ఇప్పుడు ఒకసారి డయాగ్రామ్ కలిగి సార్. డయాగ్రామ్ 15 14 ఇక్కడ ఇది మనం లైన్ ఇది మనం 60 degrees యాంగిల్ డ్రా చేసాం కదా, ఇది మనం ఎందుకు తీసుకున్నాం సార్ బ్రేక్అవే పాయింట్?
How to get symmetric without breakaway point?
We can't get.
That's all. Okay.
Sir, okay. సార్ ఇది నాట్ లోకస్ ప్లస్ అంటే ఎలా తీసుకుంటాం సార్? అంటే ఫస్ట్ పాయింట్ ఇది ఇక్కడ నాట్ రూట్ లోకస్ అంటే ఫస్ట్ తీసుకుంటాం.
Count right side odd aya. I told very clearly.
Count right side odd.
Count right side odd. Odd is there root locus. Otherwise no root locus.
ఓకే సార్. అంటే మనకి ఉన్న పాయింట్స్ ఇప్పుడు పాయింట్స్ S-5 అలా కూడా తీసుకోవచ్చు కదా సార్? అంటే రూట్ లోకస్ పాయింట్స్ ని.
What I told, third rule, what you listen, you tell. The point should not take at pole location. I told very clearly.
Okay.
You should take the point middle of the poles, na?
Middle of the pole, yes.
Middle of the poles and zeros, you have to count to right.
Okay, sir.
Okay.
Got it, sir. We should not take it.
Read first, everything read today, completely read 3-4 times, then you will get it, okay?
Okay, sir.
Next. Surya Lakshmi.
Yes, sir. Page number 4F.
4F, amma.
Yes, sir.
Tell.
Here, how we get plus or minus 180 degrees, sir?
Angle of -3, how much?
180 degrees.
That's all.
But here there is a 0 degrees also, sir. But why we can't take
0 means positive real axis.
Okay.
If number positive, 0, number negative, plus or minus 180.
Okay, sir. Okay.
Okay, na?
Okay, sir. Thank you.
Naveen,
Sir, page number
voice not clear. Set the mic and everything.
Hello.
Check it. Tell. Tell. Voice
page
not clear.
number
Voice not
14F,
audible.
sir.
Hello.
Hello, sir.
Tell.
Hello, sir. Hello, sir. Page number 14F, sir.
Tell, man. Tell. Tell.
Uh,
Hmm. Tell.
Sir, page number 14F, sir.
This is only 14F. Okay. Venkatesh.
Sir, in
Tell.
page number 6F, sir.
Hmm,
6F, sir.
Tell. Amma. Tell.
Sir, how do you draw the oral branches, sir?
Here, where is root locus branches here?
Next, sorry, sir, next page. Next page, sir.
P plus Z equal to odd. You take a point here, right side, P plus Z equal to how much?
Not here.
Right hand
sir.
side.
It's After completing 2 rules, you said one problem, sir. 2 or
Which
3
one? This
rules.
one?
Yes, sir.
Tell.
This one, sir. This one only.
Tell.
Sir. How you drawn this oral branches, sir?
Take a point, count right, na. If you take a point here, count right, how much P plus Z? Right side P plus Z, how much, amma? One pole, na.
Yes, sir.
That means P plus Z equal to 1. 1 means odd. Odd means root locus. If you take a point, count right, how much? If you take a point here, count right, how much?
Which point, sir?
Number of poles and zeros, how much, amma? To this point, right side, how many poles and zeros?
2, sir.
But odd or even?
Even, sir.
Even means root locus or no root locus?
Okay, sir.
Got it?
Okay, sir. How we decide
Odd
which
means
point
root
is
locus,
infinity
even
and
means
which
no root
point is
locus.
zero, sir? How we decide which is k equal to infinity, k equal to 0, sir?
Last class you didn't attend?
I attend, sir.
I told not poles, what is the k value? At open loop poles, k equal to 0. At open loop
Infinity.
zeros, k equal to infinity. I told in the last day.
Okay, sir.
At the end, I told, na.
Okay, sir.
Root locus branch should be start at k equal to 0. That is called open loop pole. Root locus branch end at open loop 0 at k equal to infinity. I told in the last day. Last
Okay,
day
sir.
PDF, once you check it, it is there.
Okay, sir.
Okay, na?
From root locus onwards, I am unable to follow continuously.
You have to study. Root locus is, if you don't have idea, you should study more. Then automatically you will get it. It is more
Okay, sir.
mathematical involved and graphical analysis, na?
Okay, sir.
We should work more.
Okay, sir.
And another thing, root locus disadvantage is 8 rules are there. Unless until all the 8 rules in the mind, we cannot construct the root locus.
Okay, sir.
That is another problem. But generally, while discussing third rule, you'll forget about first, second. That is the problem. That's why your rules you mug up.
Okay,
You mug up all the rules. All the rules should be in the mind. Then only can able to draw the what root locus. Another thing, they don't ask the root locus diagram generally for 2 marks. They'll ask individual rules only. Angle of asymptotes or centroid is like these questions, they will ask for 2 marks. So you should be perfect in individual rules first.
Okay.
Okay. Read well,
Okay.
then you can understand. Okay.
Okay. Okay, sir.
Work it.
Thank you,
From
sir.
last day I started root locus, na?
Yes, sir.
PDF is there, na? You work it. I
Okay,
think
sir.
they uploaded even recorded videos also, na?
Yes, sir.
Listen 1 or 2 twice. Okay.
Okay, sir. Okay, sir.
Next, Bhargavi.
Hello.
Tell.
So can we say for each and every break-in point, there exists a breakaway points?
Not all. Some cases may not. For example, see here. Here in this case, here break-in, breakaway is there. Here break-in is there here. Is there break-in here?
No break-in, sir.
That's all. Not
sir.
compulsory.
Okay, sir. Thank you, sir.
Okay, ma. Next. Naveen.
Sir, page number 14F, sir.
Tell.
Sir, here in poles S is equals to 0 and S is equals to -5. K value 0 and here also K value is 0, sir.
All
are
the
said
poles
that-
K is 0 only.
Yes, sir. You say here you drawn increasing, no, sir. It is going
K
away.
increasing, this is the path.
Sir, at a pole -5, K is moving away, sir. And at S is equals to 0, pole is moving away. And how it, in between there is no 0, no, sir. How it is moving?
Root locus branch is there means it moves. It is not that 0 should be there
But
between.
you said that
0 is there here at 60 and 300, na?
it's 60 and 300 there, sir. But here not there.
Not there means it won't move on the root locus. What is the meaning of root locus branch?
It is moves from K equal to 0 to K equal to infinity. That is pole to
Pole
0.
should move only on root locus branch.
Yes, sir.
If you don't collide, how can you leave the poles? Real axis?
Yes,
Where
sir.
are the zeros? It is like imaginary complex conjugate. That means real poles should move
Yes,
towards
sir.
the zeros, na?
Yes, sir. Means this 60-degree line means along the line the zeros are there, no, sir?
Along the 60, 0 is there.
Along 300 also zeros are.
0 is there.
Then no, it's okay, sir. Okay, sir.
Sriram. No. Lakshmi.
Sir, sorry, I am asking again. Page number 4F, sir.
Tell.
Why you are taking 0 degrees by 180 degrees plus 0 degrees plus 0 degrees is equal to plus or minus 180 degrees, sir? Why you
Angles added or producted, or what we will do angle? Angles are added and subtracted. You want to write 0 by 180 equal to 0 degrees, huh?
No, sir, no. Okay.
0 by angles are always added and subtracted only. So denominator angle is there, it will come to numerator. So plus or minus 180, it will become minus or plus 180. Minus 3 means here. What is the angle for minus 3? Plus or minus 180. Angle of plus 2 means here. What is the angle? 0 degrees. Angle of plus 7 here. What is the angle? 0 degrees.
Okay, got it, sir.
Sriram.